This is the question that we had started yesterday. Question number 8. If non-parallel sides of a trapezium are equal, prove that it is cyclic. Question number 8 from 10.5. I didn't mention that this question can be asked in another way. Prove that an isosceles trapezium is cyclic. So isosceles trapezium will be a trapezium in which the non-parallel sides are equal. Morning, beta. Let's write down the answer for this. The proof is similar to the question we did in 8.1. 8.1 last question, where you had to prove that the diagonals of an isosceles trapezium are equal. So you'll be constructing perpendiculars, draw perpendiculars from the endpoints of the one to the opposite parallel side. So in this case, I've taken trapezium ABCD. The pair of parallel sides is AB and BC. The non-parallel sides AD and BC are equal in length. You have to prove that ABCD is cyclic. We shall prove that any one pair of opposite angles is supplementary. So what I've done here is I have drawn perpendiculars from A and B onto the sides CD, AM and BN. And since these perpendiculars represent the distance between two parallel lines, these two will be equal in length. So I'm going to prove the congruence of triangle AMD and BNC. This is something we did there. So I'm directly going to write down the congruence for the two. Let's write down in triangle AMD and triangle BNC. You have the perpendiculars equal, AM and BN are equal. These are the perpendicular distance between two parallel lines. Then you have angle AMD equals to angle BNC. Each is equal to 90 degrees. Along with that, the third condition is from the given, the pair of non-parallel sides of the trapezium are equal. So which rule will be applicable for the congruence of the two triangles?
RHS.
RHS rule, the two triangles are congruent. Triangle AMD is congruent to triangle BNC. From here, I can conclude that angle D is equal to angle C and angle DAM is equal to CBN. But I will be just taking one pair, the one which is convenient for me in this case. So I'm just going to take angle number 1 equals to angle number 2. This will imply that angle number 1 equals to angle number 2 by CPCT. Please make sure that you mention the angles in your figure whenever you're using numbers instead of names. So angle 1 equals to angle 2, but angle 1 plus angle DAB is equal to 180 degrees. So angle number 1 plus this angle. These two angles are supplementary because these are co-interior angles. Replacing angle 1 by angle number 2. And now you can simply use the names of the two triangles, the two angles that you have. Angle number 2 is actually angle C and DAB is none other than angle A of the trapezium. So from here, what you have obtained is sum of the opposite angles. One pair of opposite angles together equals to 180 degrees, angle A and angle C. So this proves that one pair of opposite angles of this quadrilateral is supplementary, and hence you can say that this is cyclic. I hope it's clear. So we have the congruence of the two triangles on the either sides, A, M, D, and B and C. Once you have the congruence, you get angle D equals to angle number C. After that, you just use the property that one pair is co-interior angles. You can take D with A or you can take C with B, and then replace the angles which you've taken equal, angle 1 and angle 2. Anyone with questions here?